NFPA 30, which is flammable and combustible liquids. It excludes distilled spirits for their sprinkler protection.
Mm-hmm.
And so, and so you're
Right.
They're special or something.
Yeah. All right. Season 2, episode 6. Yeah. I'm Kenny with Carter Huddleston. We are Permaziv, trying to make engineering accessible in the light commercial market and multifam market. Go to our website, check out the old instant quote, get a price for engineering. We're here to talk life safety professionals. We promised you we would, and here we got the experts today. We're going to talk about them sprinkler pipes and how they end up wherever the heck they want to go.
That's right.
And talk through the design and things about this industry. So buckle up. Should be a fun conversation. All right, cool. Well, welcome. Why don't you tell us why sprinkler pipe? I'm just kidding.
Yeah.
A little bit
Right
about
into it.
yourselves. Austin, you can start with you.
Yeah, so I'm a fire protection engineer from Louisville, Kentucky. I work for performance-based fire protection engineering. Really a pretty diverse background in fire protection, anywhere from design of sprinkler and fire alarm systems, and now we do performance-based design, get into some modeling, fire modeling, smoke control systems, a little bit of everything, some government, federal, military background, work type.
Yeah. My name's Sean, and I work for KLH Engineers. We're based out of Fort Thomas, Kentucky, just right across the river from Cincinnati on the obviously Kentucky side. As far as my background, I was a firefighter in various capacities for approximately 12 years before transitioning over to the engineering side of the industry. So I've been doing the engineering side for coming up on 4 years now. So I think I bring a pretty unique perspective.
Oh, yeah. Are you
From that.
licensed professional too?
Not quite yet.
Okay.
I literally just got my results for my FE
FE?
last
Oh,
week.
nice. wow.
Passed. Yeah.
Nice. Congrats. Yeah, that could have been a
first
sore
time.
spot. Yeah.
Yeah.
If you fail.
Exactly. Yeah, exactly. I wouldn't bring it up if I had failed.
Yeah, no,
you know?
not yet.
Yeah, exactly. No, but first time.
Yeah,
the,
congrats on that. That's
Thank you.
huge.
Yeah, man,
Yeah.
that's awesome.
the FE is, I thought harder. For me, it was harder than the
It was.
PE.
Yeah. There's not a fire protection one. So
Yeah, it is all of the chemistry and physics and calculus that just is immediately out of my brain as soon as that class is over, and that you have to remember to do.
yeah, and you've been out of school for a bit, so
Yeah.
that makes it
I have,
makes it
yeah.
tough.
Which one did you take?
It was the industrial and systems.
Okay, that's the one I did.
Yeah.
Yeah.
A little bit more statistics, I think. A little bit less calculus.
So yeah, that's awesome. So you were in the Air Force, you said?
Yeah, that's right. Joined the Air Force back in 2009. Went in as a firefighter. I had never really even considered being a firefighter or in the fire protection industry. Fell in love, with the career in the career field. And from there, I was like, well, this is my life's calling. So, yeah.
Yep. I feel like so many people find fire protection engineering in just random ways. I mean, no kid is like, I want to be a fire protection engineer when I grow up.
I know, right?
But a lot of us find interest in the firefighting side of it. I had some experience as well with
that
volunteer
makes sense.
firefighting.
Yeah.
And then going to school for engineering. It's like, well, is there a way to mix the two somehow? And so found fire protection engineering.
That's interesting.
Yeah.
So fire protection engineers are the kids that stayed true to the I want to be a fireman when I grow up.
That's right.
I hadn't thought of it that way, but
They're like, I'm going to do this.
That's
Make it a little safer.
That's right. Yeah.
Yeah, that's awesome. Because I always talk about something similar to what you said is no engineer goes into this industry that's electrical and mechanical being like, oh, I can't wait to put rectangular pieces of metal in the ceiling and blow air through it.
Right.
Like that's not the dream. It's you get into mechanical engineering probably for some other reason. You want to do jet engines or some cool shit, and electrical engineers want to be doing Tesla or whatever, and printed circuit board stuff or microchips and CMOS transistors and all this other stuff. And then we end up being here. I mean, like, wait, what? This was a coincidence for me that I even do this. Just the job that hired me. And I was like, you're going to pay me how much to draw triangles on a piece of paper? Like, that's weird.
Yeah, exactly.
Because I did the recording studio stuff we were talking about earlier before. And that's like I was broke, working all the time with other clients. I had no money. And then I go in and somebody's going to pay me to draw pictures. I'm like, you got to be kidding. But I was actually an electrical engineer so that I could create studio equipment. That's why I did it.
Okay.
That makes sense. Yeah.
It was no rational basis for income at all. It was just like, I want to make my own equalizers and compressors and stuff. But found myself here, and now I'm trying to figure out how to optimize the engineering world, at least in the light commercial market. And the thing that comes up quite often is we do the mechanical stuff. In a light commercial market, there's always low fee, low budget for the design. Mm-hmm. And then we end up getting burned because we're not paid to do a high level of coordination and thought in the design process. And everybody always says it out loud, I just want a permit drawing, a permit set. Well, that technically means if you got your permit, you're good. If there's missing information or issues or things that have to be dealt with in the field, that comes along with that territory. But people always forget that's what they asked for. And that's why it was $30,000 cheaper. And then they look at us, man, why did the duct cross, blah, 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 or whatever. Mm-hmm. And then another thing that often comes up is them sprinkler pipes just show the heck up wherever they want to go.
Yep.
So what does that look like? Because we don't usually have sprinkler shops. It's like that one discipline that's always eluded me, that why they can just go last and just go where they want. Like, what does that workflow
life
look
safety.
Yeah. It's life safety. Yeah.
It's the morals.
Yeah. Like your air can go wherever you want, but just water has to land here during a fire.
Yeah.
Is it, I don't know what it looks like in your design world. Are you integrated into the design early on, or is it common that you're laid into it like a design build?
Well, I think it, sort of depends on the project, right? So, from my end, I tend to get more involved in, sort of the initial design process. We get, our clients will come to us and have, a pretty far along sort of, building when the MEP, side comes into it. Because I work for like an MEP firm, and we are 100% Revit, so everything that we do,
heard about that transition.
Yeah, exactly. Yeah, so I'm not going to get into any of that. Go and listen to Max's episode. But with us, I try to make sure that where I'm placing pipes and stuff like that, I'm conscious of where the HVAC ducts are being placed and things like that. So
but yeah, I mean, to your point about budgets, I mean, really nobody wants to pay the fire protection engineers to go into great detail on laying out the piping and making sure you're completely 100% coordinated. Mm-hmm. I mean, that's definitely an area where we just want the permit.
Yep.
Give us the bare minimum. But, we also have clients where, coordination is very critical. And fire protection, we'll get into, I'm sure, is way more than just sprinkler pipe, right? And laying out the sprinklers, but it is one of the challenges is how far in depth do we go with the preliminary planning of the sprinkler system and coordinating with other disciplines, and how much is in the budget?
Yeah, there's so much consulting, I guess, that would go into figuring out where how to do your design that's based on how the space is used, right? And then that also ends up influencing our decisions. And that's where I think a lot of times the line in the professional world gets blurred. Storage is a good example. You probably know more than me, but I do know that some storage sizes, if it gets certain size, you need certain considerations for smoke purge and all this other stuff. And it's difficult as a mechanical professional to know when that's necessary. It's not part of our scope, but it can be, will obviously be looked at like, why didn't you put this in here? Like, well, you needed a life safety professional to make that determination to help categorize these spaces. So how often is it that somebody knows that going in and they reach out versus it's some HJ gives a comment and suddenly you're part of the project?
It's such a mix. It's such a mix. I mean, we get called so often because there is an AHJ that's caught something, whether in plan review or out in the field.
Yeah.
But you're right. I mean, sometimes, the architect or the MEP firm that hires us just wants us to do the sprinkler planning and sprinkler design. Mm-hmm. But then you're right. You get into things like, okay, well, we have a warehouse. Do we want to protect this with ESFR sprinkler protection and avoid roof vents or mechanical smoke purge?
I totally know what ESFR, but for those that don't know, if you want to elaborate.
Early suppression, fast response, basically flowing a ton of water through large orifice sprinklers and trying to activate those quickly and quickly suppress the fire.
Yeah. Oh, man, that's crazy. And then there's also the other side of category definitions that involve hazardous materials and how to deal with that. Is that stuff that you guys have experience with it yourselves, or do you do that as part of your consulting? Yeah.
Yeah. And it's a lot of educating on, to our clients, because a lot of clients or potential clients that we reach out to, I say I'm a fire protection engineer and they're like, well, we already have someone that designs the sprinklers. Mm-hmm. And I'm like, but there's a lot more.
Yeah. Yeah.
There's, and you get into things like hazardous materials and control areas and maximum allowable quantities to make use with your hazmat and things like electrical classified areas. You need class 1, div 1 areas, electrical explosion protection and things like that.
Yep.
And that is in the NEC, that class 1, div 1 stuff, but is it elsewhere defined? Like is there some other roadmap you have to take to figure that out? Or because we have it shown, and I think it's intended to be more about, hey, here's what these spaces are, but more importantly, here's what you do when it's that space. Yeah,
a lot of it does come from the NEC, but there are some standards, say with DISCUS, DISCUS, which is the Distilled Spirits Council of the U.S.
Okay.
And so they have their own for when you're trying to protect distilleries that are making, say, good Kentucky bourbon.
Oh, right? Yeah.
There you go.
Yeah.
Shout out 4 Rows.
And they actually, based on industry best practices, put together their own standards that lay out a lot of their recommendations for classified zones for explosion protection.
Yeah.
So, for instance, what area beyond a column still that's making bourbon do you need to have classified zones?
That's interesting.
A lot of it does come from the NEC, but you have other things like DISCUS and other industry standards that have recommendations.
How does that get brought into, so those recommendations, is there a reference to the code that says when you're doing a distillery, bring that in? Or is that you just follow that practice, I suppose, when you do performance-based work?
Yeah, that's a good question, especially with the bourbon industry here in Kentucky. For example, sprinkler protection. NFPA 30, which is flammable and combustible liquids.
Yeah.
It excludes, distilled spirits for their sprinkler protection.
Mm-hmm.
And so, and so you're
Right.
They're special or something.
Yeah.
NFPA 13.
That's right.
Doesn't cover it.
Yeah. Yes.
So really, it's like, well, what do we go by? Some of for instance, FM Global might have some recommendations.
Yeah.
And so you've got to rely on things like that with FM Global or DISCUS to, have something to go by as far as how do you protect these occupancies.
Mm-hmm.
Sure. And, you also want to, consider, good engineering judgment on a lot of, on some of these things too. Right. So, from a life safety perspective, from a fire protection engineer, and even from, a firefighter's mindset, right? We always want to make sure that we're being conservative, but, that conservatism up to a point, you're just adding more dollars to a project, and what value are you actually getting out of it? So that's where that good engineering judgment comes into play. Do we need to, provide this level of sprinkler protection if it's going to mean that, we have to install a fire pump? And if we have to install the fire pump, what does that mean for the electrical systems and so on and so forth? So, getting fire protection involved as early on in your projects as possible can save you a lot of headaches further down the line.
I dealt with that recently about, the code being a design minimum, not a design standard. And we had 20 amp circuits in an apartment, which is standard. And one of the owners called and said, can we just do 15s? Like if 20s aren't required, why are we doing 15s? And I'm like, yeah, because 20 gets you a lot more. You're not going to have breakers tripping from space heaters and everything. And just, I think Kenny and I had the conversation. It's just some folks just think we just designed code minimum when we can, but we also got to incorporate our best practice of what we think is best.
Yeah. And we get into that a lot with, like, say, warehouses, where the current tenant that's moving in may have a specific commodity they're planning to store in a certain arrangement. But how much flexibility do you want to add for the building owner? Say, if they want to come in a few years later with a different tenant, or the tenant changes how they're storing things or what they're storing, how much flexibility do you want to build in with going back to the ESFR system? You could protect it at a minimum for what's provided at the time, but let's plan for the future.
It's crazy to me that this discipline, even within the professionals, is so vast. I guess what I'm hearing is a lot of people just think it's just sprinkler pipes. Like, hey, can you do sprinkler? And it's that simple, but it's totally not. That even within the professions, you have to lean on each other to be like, hey, I have an atrium or this special condition. Can you help me? If you've done this before, we have a similar thing in our world. Where does that line kind of get blurred and confusing within the professionals, you know?
I think from a fire protection engineering perspective, at least in the U.S., we're a pretty small community, I would say. There's only a few universities that have, fire protection engineering degrees. Obviously there's not tons and tons of people, as we've, already mentioned, that raise their hand as a little kid and say, I want to be a fire protection engineer, right? So, I think because we are a small, tight community in that sense, if I know I've recognized that, this is a job Austin can handle, I'll give him a call and say, hey, help me out here, send me a proposal, we'll pass it on or whatever. So, I think that's, part of it.
Yeah. I mean, you would think fire protection engineering would be a pretty narrow field, right? Fire protection, maybe sprinklers, fire alarm systems, things like that. But there's such a wide range of things you can really dive into in fire protection engineering that it's really hard to be an expert in all of it.
Well, you just threw out a couple NFPA references, but then you got the fire code, which is two giant books in the ICC codes by themselves. And
right.
That doesn't include the fact that now you got NECs, whatever thing gets brought in by reference there, and on that ICC IFP or whatever it's called, International Fire
IFC, International Fire Code,
right? And which I understand to be two giant thick books,
right?
And so there's that, and then I'm sure everywhere you turn, it's like, oh yeah, by the way, when you come across this, go to this other 40-page thing from the NEC that's been published, and you got to know that. And to me, that's nuts.
There's so much, and it's so easy to overlook something in the code and not realize that you're missing it. I mean, and that's why we have code experts. I mean, we have some staff on my team that is really what they specialize in, is knowing the code. And even then, it's still hard to know all of it. There's just so much, and it references other codes and other standards, references other sections within that code. And it's so hard to know all of it. So really it's, with fire protection engineering, it's building out a team of people that really can cover each of those areas, whether it's smoke control systems or fire and egress modeling, or sprinkler design, fire protection systems design. There's just so many different areas to cover.
Do you end up with a fire marshal? That's always been confusing to me, the fire marshal's authority, how it's defined. I've looked into the varying cities and where they define the authority, and they're essentially to enforce the fire code, I believe. But sometimes we'll have a fire marshal that I feel like just pulls a reference out of thin air that's not necessarily the code. And I've always wondered, I mean, they don't have the authority to make it up, do they? They have to only enforce what is the law, which is the building code. Sometimes I get the sense that it's like a person who has very strong convictions about how things should or shouldn't be done to make it safe. And then they'll just pull up a requirement. How's it supposed to work? Not to put you on blast.
You just open a can of worms there. I don't know if I should answer that really, but
we love all the fire marshals and AHJs.
Absolutely. And obviously, I think they play a vital role, right? Obviously, in keeping our buildings safe and everything, right? So, I think from to answer your question. Every municipality that's out there has had different experiences with fires or issues in buildings that they've seen. So as the fire chief or whoever the AHJ is growing up, they might experience something, and then they think to themselves later on, oh, when I'm in a position of authority, I'm going to enforce this particular rule. So I think early coordination with whoever that AHJ or building official is vital, right? Getting in contact with them in projects, saying, "Hey, what are your special requirements? Do you have anything that I need to know about that is going to trip me up later on?"
Yeah, and beyond specifically working with them on projects, Sean and I are on the board for the Society of Fire Protection Engineers Kentucky chapter, and we invite AHJs to all of our meetings because really a big key part of it is educating them. And it's not just us trying to educate them. I mean, they educate us on what they're seeing out in the field and some of the issues and challenges we're dealing with in their jurisdictions. And it's always great to have their input at those meetings, because it's, another set of eyes out in the field. But yeah, it can be tough because there are certain jurisdictions you might, really have battles with. What does the code mean here? What is the intent? And are we satisfying the intent, even if it's not exactly how you feel that it should be done?
One thing it's a common theme in these conversations is that nearly zero of the problems that come up in construction are technical. They're always people problems. And it's understanding that as an engineer, we were talking before the podcast, as much as I wish I could stay behind my desk and not talk to anybody, the job involves a skill of sales and soft skill that, persuasion and all that kind of stuff, make people not be confrontational. We as engineers don't have the best reputation for being the easiest to work with, and we can come across as condescending. I don't know how not to do that when you're talking about a very technical thing. We're like, well, technically the code reference here goes, so you're wrong in a very technical, annoying way to explain, and there's no way for me to explain it without sounding annoying.
Yeah.
And it just makes it worse when it's just we talk about that relationship. I've been telling people, I know that I'm at the right spot in a relationship if I can text a meme to whoever it is, and know that they'll be like, oh, that's funny. We talked about, because that means that likely we'll be able to be honest with each other and get to the bottom of it. AHJs are troubling because they're so formal. I even invited one in Richmond, the plan reviewers there, to be on the podcast, but they can't because of some whatever media thing. So now I'm trying to reach out to the mayor directly and say, what do I got to do to get your city represented here in the conversation? Because it's not looking good. And you need to stand up for yourself, like speak to what your responsibilities are, why you make the decisions you make, And we'll see how that goes. But there's like a curtain or a wall that prevents some good relationship building sometimes.
Yeah. And it's interesting. I mean, certain AHJs will focus on certain things. And just like we were talking about with fire protection engineers, how there's such a vast range of things you should know as a good fire protection engineer. Those guys have the same challenges with knowing all the codes that they're enforcing. Yeah. And so, for instance, my firm, we do a lot of smoke control system design as well as special inspections and testing. And, in many jurisdictions, we know there's buildings that are not being tested properly for smoke control systems. And so really part of what we want to do is build a relationship with some of the AHJs, provide some education. And, part of it too is getting certified in certain states to be able to provide the hours they need as inspectors, so that they can, benefit from that, to be able to, maintain their certifications, but also, learn how to do their job better with enforcing things that they may not realize they're not enforcing properly.
Especially the smaller jurisdictions, they have sometimes one code official that's charged with enforcing everything. Yep. And if you got an army of fire protection engineers still trying to share the knowledge and become specialized, good luck being that one code official.
Well, yeah. And you bring up a good point on that, actually. Sometimes depending on the nature of the job, it's not uncommon for a local municipality to hire fire protection engineers to do, their plan reviews, and, act as that, sort of code official. Right. So I've seen that and been involved in that, from the person being hired by an AHJ. Right. Yeah. So
interesting.
Yeah. Third-party reviews, peer reviews are very important, especially with like the services my firm offers with performance-based design, because you get into a whole nother level when you're taking a performance-based design approach versus following prescriptive code requirements.
Yeah, that's definitely going to be part of this conversation I want to dive into. By the way, we'll have your logos when we start the whole thing, but KLH, this is day 2. We had the Max.
That's right, yep. LevCon,
yeah. With us talking technology, here we have one of the engineers, and then, of course, Austin from Performance-Based Fire Protection.
We have too many words in our name.
That's right.
It's an awesome
Performance-Based Fire Protection Engineering.
My favorite part about that name is it is just exactly what the code is usually in the NEC. Like grounding electrode conductor the definition is the name.
Right.
I've been an electrical engineer for so long, and scratching my head, grounding electrode conductor, equipment grounding conductor. What are these things? But then one day it just hit me. Oh, they are what they say they are. Right. It's the equipment grounding conductor.
Right.
It doesn't need a definition, and your business name is basically the same thing. But for me, I didn't notice that until, much like the way I learned grounding electroconductor, that performance-based engineering in general is a completely different approach to design for fire protection. So walk us through what the difference is in the two approaches.
Yeah, so generally diving through those big code books you were talking about with the international building codes and the fire codes and things like that, you have prescriptive requirements, right? Everything from egress travel distances to how, what types of buildings have to be sprinkler protected to what needs fire alarm systems. And, the codes give you a prescriptive approach, right? It's kind of almost like a checkbox approach. Like, okay, the building's this size, then you must provide this. You have this type of occupancy, so you must provide, a travel distance within this range. So what performance-based design is really, instead of following prescriptive requirements, it's taking a goal-setting approach of, okay, what are the actual objectives? What are we trying to accomplish? And, ultimately we're trying to provide a level of safety for the occupants in the building, right? And depending on, acceptability of risk, we may have additional goals that go beyond that, whether we're protecting property, business continuity, providing safety for firefighters and first responders that are coming into the building. So we're setting objectives, and we take a technical approach to prove that we're meeting those objectives through the design of the building. And so instead of check the box, it's okay, well, let's actually look at several different potential fire scenarios that are realistic possibilities for happening. We're not saying worst case, you could always think of a worst case situation, but what are realistic possibilities of a fire in this building? And what are some ways to mitigate the risk there? And can we implement a design that actually, meets our objectives for building life safety?
Is there a way in that code, the way it is for the energy code, when you're trying to do an alternative approach, you have a baseline calculation based on what the code's baseline is, and then you can design in a different model in the energy model that'll tell you whether you've exceeded that or met that baseline? Is there something similar in your modeling where you kind of can calculate a baseline?
Yeah, so there is a section in the building code that addresses alternative means and methods, and that's what we fall back on. And so it comes down to often, okay, what is the intent of the code? So, for example, a smoke control system, what are we trying to do? Generally, we're trying to maintain tenability in the space where the smoke control system is provided. So through CFD fire modeling, we can look at different fire scenarios based on, what the fire hazard is, what could potentially be burning, look at the occupant load of the building and model the egress out of the building. And look at, okay, with these different scenarios, do we have tenability within the building? Can the occupants see to get out, to get to an exit? Are carbon monoxide levels at an unharmful rate, unharmful level? Temperatures, are we, below certain temperatures to keep people safe? So we're looking at all of these tenability criteria, and we can look at that through fire modeling and pair that with our egress models.
What do the standards look like around that? Like, are there, I know you mentioned with the distillery, there's that kind of people that make those kind of specialized standards. Is there a performance-based standard out there that defines the inputs and outputs of the model, or what's acceptable there?
So yeah, generally we'll fall back on Society of Fire Protection Engineers. There's actually a guide to performance-based design, and that's pretty much the industry accepted.
To those guys, it sounds like they're pretty important in this industry.
Yeah. And as Austin is saying, that guide does provide you with, various sort of standard tenability requirements, how hot, the gas, layer can be, for example, over, a certain amount of time, right? How long you can be exposed to carbon monoxide and at what levels. And, typically, as Austin has said, you take that objective mindset and work with your AHJs and say, look, these are the criteria that we're going to set for this model. And please correct me if I'm wrong here. I've just read them. I haven't actually been involved in a lot of developing of them, but you set those criteria, and it's all agreed upon by, the owners, architects, interested parties, right? And they run their models, and if it meets the criteria and everybody's happy, great. If it doesn't, then send it back to people like you and me to fix stuff, right?
Yeah. What does the review process look for that from the HJ? Like, how do they even review that?
So, going back to Sean's point there, he had a good point about early on, you want to make sure everyone's agreeing to the right, the fire sizes, the right characteristics of the fire, what's the hazard, what are our tenability criteria that we're evaluating for, what are the goals and objectives. And so we put all of that into a document called the design brief. And that's before we start running any fire models or egress models or actually doing the full evaluation. We're actually documenting, okay, what is our approach going to be, and what are the criteria we're looking at, and basically what are the inputs to our models. And so we issue that to the HJ, to all of the stakeholders for the project, and we're looking to get buy-in before we spend all of the time evaluating these different fire scenarios, only to be told, hey, we don't like that scenario. We want a larger fire or a fire in a different location. So that's the initial step, is getting that approved and having those conversations. And a lot of times they'll have good input, right? They'll say, well, have you thought about, because of this specific type of building and how it's going to be used, have you thought about this specific fire scenario? And they're like, okay, that's a good one. We'll add that one as well. And so then we'll actually do the full analysis, go through the modeling, document everything in a report, determine whether the design meets those goals that we set or not. And if not, then we work with the architect and the engineering team and the owner to come up with some solutions that make it work.
Yeah.
And then put all that into a report. And then that final report, the performance-based design report, is ultimately what's reviewed and hopefully eventually accepted by the AHJ.
Man, that seems crazy. So this design brief, is this part of the outlined code requirements, or is this the standard that you follow? Or, I guess I'm leading into the question of who is the final decision maker of what risk to accept at the end of the day? Is this the engineer's decision? Is it the owner, occupant, the HJ? Because at some point somebody has to decide, like, this is as big of a fire that we'll model. Like, we're fine with the bigger fire causing more damage, and somebody has to be a part of that decision making, right? And who would that be?
Right. Yeah. I mean, and again, we go back to the team of stakeholders because it is multiple people involved in making those decisions between the building owner, the HJs, the first responders. And it's important to have those conversations up front and have everyone be on the same page.
Yeah, I guess the fire marshal's big on that conversation, I reckon.
Yeah, and we try to address their issues. They'll often have concerns, and obviously they're looking out primarily for life safety, right?
Yeah.
And they want to make sure the occupants are safe. They also want the firefighters to be, they don't want the building collapsing on their firefighters and first responders. So those are the big things they're looking at. But then your client or the building owner may have additional goals beyond that of, hey, we have, say you have a museum with critical pieces, in their archives, and they don't want those items to be smoke damaged, so then it's something beyond code minimum and beyond just life safety, but protecting the contents of the building or being able to maintain the business operations, say for a data center or something like that.
It's also depending on the building that you were discussing, or as part of that particular project. It could be something that's vital to the whole community, and it's going to be insured, right? But that's only going to cover the owner, right? Let's say it's a massive distribution center that's out in the middle of Kentucky somewhere, or Virginia. If that building goes down for whatever reason, catches on fire, fire safety wasn't as important of a sort of line item for the owner at the time.
Yeah.
Well, what about the rest of the community? What about those guys that worked in that particular, factory or whatever? If that goes down, that whole community could be wiped out. The owners will be okay because they'll get paid off, right? Most likely. But, that's something to consider as well.
Yeah. Art, you can maybe replace that with dollars, but not, it's going to be gone forever if it's a priceless piece of artwork. That reminds me of like the generator consulting when we do that, because there's the emergency requirements on generators, life safety systems, lighting and all that. Then there's the legally required kind of things that show up like elevator. And then you get into the categories of, what is it, 702, where it's optional standby.
Yeah.
It's like, oh, do you have food storage? You want to keep your, are you fine with losing all that inventory if you lose power, or do you want to spend the money to power that on an optional standby basis? So the fire protection has similar worlds. It's like, all right, we feel comfortable that people are safe as reasonably, that the risk we can accept here. Now, do you have anything really expensive or whatever that's vital to your business operations, artwork? I never even thought about that.
Right. Do you have data centers that are, if something happens in that data center and there's a fire and you're losing, all of these businesses that, their ability
Financial transactions and stuff.
Yeah, their ability to operate on a day-to-day basis. I mean, very critical.
Man, that's crazy. You were mentioning before, there was like this smoke control system where it's like $1 million a pop on something or the other. And then that's where we reach out to somebody like you can help us do some modeling and maybe replace that. And I'm sure it's hard for people to justify paying any engineer to do anything because they don't feel like they get anything as a result. Yeah. But in that case, you're getting $4 million less of equipment or something in exchange for maybe a $50,000 study or whatever, right?
Right. Yeah. With smoke control design, I mean, there's NFPA standards, NFPA 92, that'll tell you, okay, here's how to design a smoke control system. And there's algebraic equations, and you just, you can build a spreadsheet or something and come up with some numbers on CFM, of exhaust that's required and things like that. And that's what a lot of people do. But really, if you take a performance-based approach to it and use fire modeling and actually model the smoke movement through the building, often you're able to greatly reduce what's actually required to be exhausted, which affects everybody. Yeah. I mean, it's not just the fact that the fans are smaller and you need less power and smaller generators. It's, affecting the architect because to exhaust more air, you need more makeup air, right? So whether that means more doors opening into the space or mechanically supplied air, duct work that architects don't want to see.
Yeah. Tell me about it.
I think the whole approach to the performance base is really underrated, because you mentioned the code is really like a worst case, and it's always like that. But when you take a performance-based approach, you have to fully understand what's going on and why you might change certain factors. Like when we try to make sense of the code, we'll ask ourselves, what's the intent, right? Like the whole fire pump section of the NEC is basically the complete opposite of the rest of the code.
Yep.
So if you fully understand that, you can make decisions based around it.
Your modeling reminds me a lot about the HVAC modeling that we do, especially with the new Trains release. This new, I think it's based on Department Energy's, forget the name of it. The way they model it now is when we do our calculations traditionally, there's a CLTD method, which takes that extreme day, their design day, 1% day, and you assume that on that day, you'll have all of the people inside of the building doing the big thing. If it's a church, like they're all, doing the church thing all on this day, and it's peak humidity, everything, and then you size your HVAC for that. But what the new method is probably something similar to how your studies are. It's like it runs through a whole year of weather data, historic weather data, and you program the occupancy of when they'll be there and not, and it'll pick a peak day based on like a statistical, all of these, it creates a virtual model of a living and breathing building, and then we'll choose your load based on the likelihood that these people will congregate during your peak hours. A church is a good example. They might be 8 a.m. to 10 a.m. Those 200 people, that's the only time they're ever going to be there. So is the weather data every weekend historically going to also going to reflect that during that time, and where the sun will be with the glazing? It'll actually take the sun and, study its impact through these windows and then give you a more accurate assessment of a better size of equipment. Whereas if you do peak demand, you're just going to have maybe 40% larger equipment. Yeah. Something similar maybe with what the performance-based is versus like the prescriptive models, right? You can actually study what may really
and there's a balance too. I mean, for instance, working on a football field house, and the client or the owner says, this is only going to be used for football practice, right? But we've seen field houses in the past used for graduation ceremonies or concerts or trade shows or whatever, career fairs, and it's like, okay, well, but do we want to base it on what you say right now? It's just going to be guys playing football? or should we actually look at a worst case with, more occupants, more fuel load, for the fire? So, having those conversations is really key. And because we don't want our PBD to limit the use of the building, right? We want to give the owner flexibility and allow them to be able to use the building how they want.
Yeah.
So that's why they're very critical and ensuring we have those conversations up front and understand, what they want to use the building for and their future plans. And because if we account for that up front in our design, then the HJ, it will be less likely to question them for, a different type of event in the future. Or we have a report to fall back on that says, oh no, we actually did look at, cars parked inside of this football field house with a very large fire and higher occupant density and having to evacuate all of these people out of the building. We actually did look at that.
PBD meaning performance-based design.
Yes.
Yes, I'm getting
Finally got an acronym.
I know, I'm getting it down.
Good job.
I wanted to ask about the just a quick side topic of what's the biggest drama in the fire protection world of everybody, especially engineers, have really strong opinions about things, and internal between the fire protection engineers, where is there like a point of contention and what does that look like?
Oh, I don't know.
I'm not trying to put you on the spot.
It sounds like it looks like Austin, you might have an answer for that. I'm not really sure.
Contention between FPEs?
Yeah, like is there like a topic where you're like, that I'd rather this be the way we do it or type of thing,
Actually, yeah, I see what you're saying. I've got an example, but
go ahead.
Yeah, newer technologies, right? From a firefighter's perspective and from a fire protection engineer's perspective, right? All of the codes that we read and design to or whatever, they're all written in blood. You know what I mean?
Yeah.
That's kind of a dark way of putting it, but there's a reason why travel distances in a building are set at 200 feet or whatever the case may be, right? So when you have these newer technologies, for example, the electric vehicles, right? How do we protect existing parking garages with these electric vehicles? Do we need to sprinkler them? And I think from an engineer's perspective, who has also been a firefighter in some capacities, sometimes we can be overly cautious, and that might be a very sort of contentious point between AHJs and the engineers, right? As engineers, we want to represent the our client, typically a building owner, right? So we have to try and make sure that we're giving them an economical building, right? It all comes down to cost, as well as something that's going to satisfy life safety requirements. So, that's probably, I think, one of the bigger ones that I've run into often. It's like, why are you making me, sprinkler this building to these particular levels? Now I've got to put a fire pump in there and also upgrade water lines or put a storage tank in here when there is no science or data to back up what you're asking for.
We're just kind of guessing it.
We're kind of guessing.
We don't know the risk data yet. And that's, it's like over design. And I hate that word sometimes because a lot of people accuse me of over engineering, but I could see the world where like, do we really need to go this far with just blowing a project budget for this? And I guess we just won't have any EVs, no vehicles anywhere type things. Like if it's that over specified, then nobody will have charging stations, and let's just go ahead and keep using fossil fuels instead,
Yeah, absolutely. That's a good point.
Yeah, I mean, I think just working in the performance-based design world, there is a lot of contention there because it's still not widely used. It's kind of a growing area because as technologies emerge and architects want to be more and more creative with their buildings, right? Performance-based design, I think, is continuing to be more prevalent. And you have people that they fall back to the prescriptive requirements of the code and say, hey, you can't do that, and we're not going to allow anything different. Yeah. And it's trying to provide the education, but also technical proof that, hey, this design concept works. And so we have had some pushback, both from FPEs that just don't really have the experience with performance-based design, as well as the AHJs. And it's tough because, right, the code book says do it this way.
Yeah. And it must be, there's a certain level of comfort. I would imagine if I'm an HJ, especially one that's understaffed, being nervous, like to do anything other than, can I verify it with a table and a code reference?
Mm-hmm.
We have NEC 90.3, right? That lets us .190. Yeah, I know. Totally professional engineer.
At church.
Yeah.
Just dealt with that.
Yeah, we try to go down that road. You can tell them about that.
Yeah, it was an existing service. We were trying to prove the load on it. We took a custom approach to doing it. It was kind of like a performance-based approach. It wasn't technically called that, but that's what we did. And we both felt confident that what we did extrapolated to the intent of the code. And this was kind of like a one-man shop, AHJ. And he was like, no, like you have to do the 30-day demand metering, even though we really thought that it was. Obviously, we wouldn't have sent it out if we didn't. But he was like, they didn't even want to entertain it at all, which I totally get.
Which frustrated us because he was also the one that sent us down the road of like, do you really need to demand meter? This must be some other option. And we were like, sure, we can go down 90.1. You just have to approve it. And here's our engineering justification for it, performance based.
We looked at the alley-oop.
Yeah, we're like, sure,
slammed it down.
You want us to do it? And he's like, nah. Now go back to the metering. And now we're like, of course, we're the bad guys. Having not, I don't know, it's tough with that performance-based approach. You got to buy in a lot of trust and make a decision based on our judgment. We had 2 engineers looking at it. Basically, the code in the NEC says if you add load, there's a certain way to do it if it's existing system. You can meter it for 30 days during peak HVAC season, but nobody pays attention to that part. Mm-hmm. Or you can do a full-on NEC calculation, but which means you have to go and identify every single thing connected to the entire building. If it's a 17-story building, that means you got to, or just meter it for 30 days and see what the demand is for a 15-minute interval. And so we had a very small project. They were adding a very small load. We made what we believed to be reasonable judgments, and he just set us up, made the client think that they could get around it by saying, oh, you shouldn't have to do that. And then we went down the road of the 90.1, got rejected, and then everybody, of course, the engineers screwed it up type thing. But is that work the same way when you go through the performance base? You have to start by getting that approved, or is it baked into the code that this is an approved method? Like in the NEC, you have to have the HJ's approval to go down that road.
Yeah, it's certainly left up to the HJ to approve. And ultimately, that's our job, is to provide the analysis, provide the documentation, and all of the steps that we went through to get to the level of design that we're at, right? And sometimes AHJs, depending on the jurisdiction, may not feel comfortable reviewing something like that, a highly technical report, right? So back to Sean's point earlier, they are perfectly capable of hiring a third-party reviewer to look at that report and provide feedback as well. And so, my firm provides that service as well, often where, the HJ is like, hey, we want a third-party reviewer, someone that knows what they're looking at when they're reviewing this report, so that we can feel a lot more comfortable.
Yeah.
Who pays for that?
Typically the owner.
So they'll pay the third party on behalf. I see. Yeah.
On behalf of the HJ.
Man, what an uphill battle. We have enough time trying to convince people MEP's needed when it's a third of the cost of almost all the construction. I imagine when it's like a phantom study that's so critical to a project that people are like, what? I can't believe, this would cost so much. And you're like, good luck trying to find literally anybody else who knows how to do this, because there's like 10 of us in the whole world.
Well, and we can save so much money sometimes too with the PBD approach. I mean, a lot of our calls that we get are, there's a fire inspector out in the field that has caught something that was missed during design, something very critical that costs a lot of money to go a prescriptive approach. And so we'll actually come up with a performance-based design and evaluate it and essentially save the building owner or developer, whoever, hundreds of thousands of dollars, because we were able to justify, an alternative method to the prescriptive requirements.
Yeah, they're happy to pay that, because if the prescriptive method means something's going to cost $100, but the performance base means it's only going to cost $50 and you only cost $10, then you come out ahead.
Yeah,
whereas the prescriptive method, we cost anything and people scream and hate us.
I know, right? Yeah, shit. The statistics is an interesting thing here. We talk about the risk that you calculate. I have that conversation with HVAC all the time. For us, it's about, my line is, you could be as comfortable as you can afford. Like, the code doesn't force you to be comfortable inside of a space. So now it's about how comfortable do you want to be? Because it's expensive to deal with all of the conditions of comfort of every single statistical load thing that could happen. Maybe at peak day you'll have everybody there. Maybe on that day they're partying and dancing, and that's a completely different load calculation than saying that they probably won't be there on peak day. and we're going to assume that they won't be there on peak day. And if they are, we just had this conversation today, then maybe they're 50 to 60 years old and there's a cocktail hour. But those assumptions are vastly different. And you get accused of messing up the engineering. So I always love telling people for HVAC. So like, we're literally just guessing, by the way. There's no secret science to HVAC load calcs. It is a guess. And if any mechanical engineer out there wants to say it's otherwise, y'all are out your mind. Because, we're guessing on the weather data. We're guessing on what the set points are. We're guessing on what people are going to do. We're guessing how many might be in there. It's all a freaking guess. So that's how we deal with it. But when it's life safety, it's got to be a lot more difficult to get to the bottom line of what do we really need to be protecting,
Yeah. And as far as, for instance, occupant loads, I mean, it's not like we're completely throwing the code book out, right? With the performance-based approach, we're still looking at prescriptive requirements for, say, occupant load. And we can go by that occupant density for the use of the occupancy and say, okay, well, the building is going to be limited to this many occupants. Yeah. And we can incorporate that prescriptive requirement into our study, into our analysis, and look at it that way.
So we dived really into the prescriptive and like how nuanced this all can be. We haven't even talked hazardous materials and all that, but backing it into a more straightforward, the average person, what they understand, like a life safety person to be, which in my assumption is a sprinkler designer.
Exactly.
What are the things that you wish you could make sure somebody knew when they started every single project? Like, what kind of checklist of things should they be asking themselves before they get themselves in over their head?
Sure. I'll take that. So coming from my perspective and my background, and then going to work for KLH Engineers, I was asking a lot of was seemingly random questions to our MEP project managers, right? Mm-hmm. Like, what is the building construction type? What is the, why? How big is the building? How many floors? Things like that maybe aren't necessarily as critical to some of the other disciplines. So I'd say from a perspective of what are some of those things that you need to know. I've developed just a list of questions that I always send to any architect or any project manager to say, hey, answer these questions off the bat for me, so that way I know how I'm going to sort of approach this design. A lot of times it might be so early in the design process that they don't have those particular answers, so falling back to the conservative side of things, okay, well, we'll design for the worst scenario, and then later on we can sort of pull money or pull things back. And
what are some of those the bigger hitting questions that you really need to get, or it'll change the dynamic of the whole approach?
Storage is a big one.
I was going to go straight there too.
What are you storing? How are you storing it? What type of containers and packaging? What kind of pallets?
Because that's where we get burned, because we're designing a mechanical system, but all the requirements of, I don't know what you're storing. And if you store something crazy, now I have to make sure something's there, that I'm not the one to decide that. And now I'm stuck in there's no life safety professional world,
Right. So yeah, I like that you're using that particular term as well, by the way, life safety, professional. I would prefer that instead of being, called fire protection engineers, because again, that does, invoke that sort of, it's just sprinklers and fire alarm.
Yeah.
Right. But if you, consider it life safety engineering, then that sort of brings in all of those other elements, into play. The passive fire protection features that are typically only, sort of looked at by architects, in the beginning.
Passive, you mean like wall construction and things?
Yep, exactly. So
fire-rated barriers,
fire-rated walls, things like that. So, if I can get a lot of those answers, up front, then again, we can maybe save some money on the back end, identify any of those issues later on.
And fire protection engineers provide a lot of that code consulting too. I mean, we work with a lot of architects that are like, hey, what can we change to, what happens if we change the construction type of the building? Maybe we could save some cost by not needing to fireproof all the structure.
We should put them in touch with we just had a project this morning that are trying to figure that out, right? That very thing, like how what's the best approach for the building, this building, what materials to use. Just talking about that. I believe that a life safety professional should be on every damn project at the early, just even if you're paying them hourly for just to show up and be a on-call I don't know. I don't care if it's a $700 bill. Just send it to me so that you can tell me what kind of things I should be thinking of, and that your radar can go off and let me know when I need a full proposal from you. Like, boom, or just tell me not to make this decision so that I don't need to spend 40 grand on some crazy study. Atrium's a good example.
Yeah.
Just don't do the atrium.
Yeah, exactly.
Well, and that's part of what we do too, is like, okay, well, maybe you don't need a smoke control system if you do these certain things to protect this atrium.
Mm-hmm. Yeah, exactly. And those kind of things, I mean, that's worth its weight in gold, but people really struggle with understanding the value of engineers because, we're the ones that draw things that can't get built all the time because we don't build this stuff. We think we're in an abstract world. We're an imaginary model, and it's hard to appreciate what's going on in that thought and how it governs what's finally decided when we finally draw our ductwork, which is the very last thing. It's an afterthought for us. And it comes across that way to people because it's their for the mechanical world, most of their work is installing the ductwork. So they perceive our design as basically ductwork. But the behind the scenes, we're having this storage conversation with a life safety professional. Like, hey man, am I going to need this smoke purge or what? What's going on? Can you talk to me about, is it going to be explosives or whatever in here? Because my guys over here in the electrical need to that's what's happening. And then it shows up as a very difficult to be built system sometimes because it's a permit set. Like we got you to permit, right? We've done all this life safety consulting and you could build this and you're just going to have to put a lot of thought on how it gets built. And that's where we get burned on the MEP side.
Yeah.
In light commercial.
I think, also to maybe answer one of the earlier questions about, when do we need to have a life safety professional or life safety engineer? I'm branding that now. I'm sure it's already been out there, but anyways, when do we need a fire protection engineer? Right. So, if you are in the federal government, or in the, operating in the federal government sort of, purview, any of those types of projects typically, are required to have a, QFPE, qualified fire protection engineer, who has a very specific list of responsibilities that they have to go through and make sure that they have checked your MEP, drawings and electrical drawings and, what the door ratings are and things like that. So, federal government can afford, those types, that extra, I wouldn't call it extra expense necessarily, but they recognize the value of that. And in the commercial world and outside, in the private sector, again, as you've said, well, we've already got an architect to tell us what, the walls are rated at, we've already got, a sprinkler designer, so why do we need somebody who has all of that sort of knowledge, and pay them a bunch of money to,
it's a lot, but I see it as a Venn diagram where like you overlap in almost every single trade.
Big time.
Absolutely.
And there's a very weird blurred line over who, each of these trades are seen as responsible for these things. And we're responsible for dealing with it. Electrical is a great example. When we know what category we're in, explosion proof conduit or whatever the heck we need to be dealing with. But you guys in that world are needing to understand a lot, even egress. I'm sure there's a lot of overlap between you and the architect and those egress decisions.
Human behavior. How are people going to react to, a smoke, detector going off? How are they going to react when they see smoke? How are they going to, what are the sort of typical, occupant, what does that look like? Are you in a dental office, right? That's, an orthodontist, or are you in a dental office that's, removing, wisdom teeth, right? That kind of thing. So, you have to take all of those things into consideration. And try to design the safest building you can.
Yeah, and to your point about overlapping with the other disciplines, I mean, absolutely. And I think a good example is a smoke control special inspection. So on the day of the smoke control special inspection, which we've already pre-planned and had meetings ahead of time with all of the stakeholders, all the various disciplines that need to be involved. But on that day, we need the full team there. We need not just the sprinkler contractor, but the fire alarm contractor, the mechanical contractor. We need the door vendors. If we have doors that are, that have to open to allow makeup air in, we need the electrician that knows how to wire that properly. And the door guy that knows, how that operator works and how it needs to be wired. There's so many different people, and the sprinkler guy knows, okay, I know how my sprinkler valve operates and how this water flow switch activates, but they may not fully understand the smoke control system is based on certain zones of the sprinkler system, and certain flow switches need to activate the smoke control system, and other flow switches may not, or should not.
Man, that's
activate.
crazy. So then you need a controls guy. I mean, and which one is responsible for which signal going where? You got the HVAC control with a smoke detector that maybe has to go over here, and some other guy that's the fire alarm control guy is receiving. I mean, the scope gap to me seems easy to fuck up real bad.
Absolutely. And that takes so much planning. And that's why it's so critical. But back to my earlier point is a lot of times these special inspections aren't even enforced. Yeah. And if they are enforced on to commission the building, these systems are supposed to be tested every 6 or 12 months, depending on the type of system. Wow. And I guarantee you, a very high percentage of the buildings here downtown are not tested the way they're supposed to.
That's wild. I mean, shoot, we've been in a couple buildings with a single HJ enforcer. I've seen some scary things just on the electrical, but that's a more direct, immediate thing to notice. So if it's already in a more established city, the training that's required to get them to even be aware of it, as less and less staff and resources for HNA, the AHJ become lower, then we end up with even crazier things. Like we've seen some really sketchy stuff with electrical. It's like legit fire hazard situations. And I always tell people, engineers, we're not just expensive because we cost a lot hourly. We're expensive because we are more knowledgeable maybe than you want us to be with the code. It's going to end up leading to expensive stuff that you have to install. So be prepared for that. Like the $50,000 fee is just the beginning. Get ready for another $250,000 of whatever the heck you would have probably not even been aware of if you just done it without that engineer. So buckle up.
Well, and to that point, I've lived in various parts of the world, some more developed than others, and I can tell you from that perspective that it's worth the money if you value the occupants' lives, right? Yeah. If you value what's inside that building, there's, again, go back to it, but there's a reason why these codes exist. There's a reason why I have to have 3 layers of Type X, chip board, whatever, to protect this particular area, that's full of, whiskey, to the, people in the offices next door. Right. So, when we talk about, fire protection engineering and some of those, programs, university programs that are out there, right. You can go into, the AHJ side of it, right? Mm-hmm. You can go into what Austin's doing, performance-based stuff. Can go into what I'm doing, building design work. But who comes up with how these materials are actually going to burn, right? Those characteristics. So you can also go into that research side and just set stuff on fire and figure out how much smoke is going to come off it, right?
I've seen some of those equations for like the different materials and like how fast or how hot they burn in the appendix of just me turning the pages. Like, man, that actually, I could totally see myself nerding out on this kind of stuff.
Mm-hmm. It's
awesome.
Just
like studying it. But somebody has to know that and figure that out. It's just crazy. The understanding how to even approach the model to me is nuts. But then understanding that you need somebody who can consult. That sales skill that we talked about, like you're talking about nearly 0 people in the world, and so
we got one right here.
We got Austin here. Definitely check them out. I mean, but we'll put links to both y'all's companies here. But the fire protection community is really tight knit. I mean, Corey knew who you were, and you knew who he was right away before y'all start working together.
Yeah, and again, I mean, so many different FPE firms specialize in certain things or have experience with a certain type of client or building, and so we're always sharing work and referring people elsewhere. For instance, my company doesn't do dust hazard analyses, so we have. People that we refer people out to for that. So
there's firms out there that like specialize in dust hazard analysis.
And it's in the NEC, so people think it's our responsibility.
Yes, exactly.
Right.
Like, no, there's a freaking professional firm billing the heck out of that knowledge because it's extremely valuable and extremely necessary, but we can't. We're engineers. We're closer to the building design, like you were mentioning. We're implementing like the prescriptive elements of the code and just, we do make some judgments, but basically we're just trying to make sure the gear is sized and we got a generator if we need and generally all this. But I want to ask this question later, the implementation, but you said something and I feel like it's the best sales pitch ever you can ask. I mean, this is for people who value human lives. Is that somebody you think you are or not?
I sure hope so, right?
Yeah, exactly. Right.
If you don't, you don't have to hire me.
I hadn't thought of it that way, but
that's the ultimate sales pitch. You can ask it in front of a whole bunch of people.
Right.
It's up to you if you don't value. I mean,
do you value human life? Really?
It's your call whether you.
If you do, then hire me. No, obviously,
you don't have to accept my proposal if you don't value human life, but it's fine. But it is true. It's definitely critical, and I think it's easy to overlook or assume every other professional is somehow preoccupied with those elements that are just invisible. The risks that are just around based on what you're deciding to store, or how much of it you're going to store, how hot this stuff can burn, how much dust there is, or Lord have mercy, the smoke and how that'll move. But one thing I wanted to ask, because we talked about that scope creep at that commissioning session or that startup or that process, right? A lot of what you're doing isn't necessarily as directly implemented as the building design. For you, you have the sprinkler spec, the pipe spec, right? You have a lot there. Then there's a lot of the life safety stuff that happens that you're providing a report for, but then it has to be implemented. So then what happens? Like everybody looks at each other like, I mean, are you going to spec that fan, or, because I don't believe you spec the fan itself, right? You study what kind of airflow would be necessary.
We work directly with the mechanical engineer to, hey, we need a fan that's going to give us this many CFM of supply air. However you duct that or size that fan, we don't care. Yeah. But we need 80,000 CFM or whatever it is.
Okay. And then the control side, I mean, is this a fire alarm controls or the mechanical contractor controls? Who does that?
Yeah. So a big piece of it is through the fire alarm system or the firefighter smoke control panel.
Okay.
That kind of work hand in hand.
Okay.
But yeah, I mean, a big piece of what the fire protection engineer is doing in a smoke control system design project is tying all those pieces together, right? Because there are so many different systems that interact, and all these systems have to integrate to provide a successful smoke control system. And so we are the person that helps the architect understand, okay, we need doors, that have openers.
Yeah, that's crazy.
And the electrician needs to know that, and the mechanical contractor needs to understand how these dampers need to be, how they need to operate in that sequence of operations.
Because the doors is like a security contractor almost, like their thing. And then you have these points. Do those points end up on the fire alarm drawing? All of that integrated stuff?
Yeah.
Okay.
Yeah. There's a lot of things that have to be monitored. You have to make sure you have power downstream of any disconnects for fans or other equipment. So there's a lot of pieces that really you need someone that knows smoke control systems on your team. And back to your point, as far as implementation, I mean, the building code requires for smoke control systems that you have a smoke control special inspector to commission the building. And again, that's typically going to be someone like us as the fire protection engineer working with a team. It's an entire team with your T&B contractor and mechanical and all of the various disciplines that have to be involved. But we're kind of leading the test and ensuring that it is properly implemented per the smoke control rational analysis.
Is that, you said that word rational. We don't have time to cover, but go Google it. That's a thing. That's like a full out thing that's defined by the code that's required as a report through the whole process. And that is not a cheap thing to get, but you do need it. But the special inspection that you mentioned, is this part of that maintenance, that 12-month thing, or is that a different kind of inspection?
Yeah, so there's the initial special inspection to, get occupancy for the building, right? Before you can move in.
Yeah.
But then every 6 to 12 months, the smoke control system also has to be tested.
Yeah. So developers out there listening, man, I can't advocate enough life safety professionals, no matter what your project is. I mean, I'm talking, even if it's a tiny little TI that you don't think, just the $500 is going to it's insurance. To help you make sure you're not making crazy decisions that are going to turn into something like, let's just throw an atrium or whatever. But even at the smaller level, we've had smaller projects that you've helped us with. It's like an auto something or the other. Hazardous materials. You never know what materials you're going to be storing that are going to just totally screw your project. And it could be as simple as just put a firewall here to make it half the material stored here and here, or something like that would change the game. And somebody to be your like radar, listening in on the whole scope, just to help you make sure you're not making crazy decisions. For us, this came up on a development recently. They were going to take over a project that was a bar and a kitchen before. They had no open cooks. So there was no type 1 hood basically. And I was like, just don't add anything that you cook with here. Just don't. And then you'll be fine. Then you don't even have to hire me, but don't add a single thing with an open cooked surface or you're screwed and then none of this mechanical will work. Don't add walls, don't change occupancy, and don't add any cooking equipment and just keep it as simple as possible. And then you don't even need to hire me. So I would have been fine charging $500 for that piece of advice because it saves them, first of all, $5,000 or $6,000 in a mechanical design if they went down the road of adding that stuff. And then, God knows, another $500,000 in HVAC equipment. That I feel like is what needs to be at the projects early on. A consultant like that every single time.
Yeah, and I think it's you spend a little bit of extra money up front, but then you end up saving. We've talked about that a little bit already, but a great example of that would be your sort of larger multifamily apartment, lifestyle type buildings that are becoming more and more popular these days. You're right. You've got, a single floor on the bottom of, a 4-story, structure. It's a podium design, right? So you've got, the bottom floor is typically made from, non-combustible materials, right? So it's cement and, things like that. And then above that, you've got, all of the wood structures, those are like type 5 construction types. Based on the type of fire sprinkler system that you install, can have a very, great impact on the building size, especially on those upper floors. So you might end up spending a little bit of extra money in the sprinkler system. However, we've now just, eliminated a bunch of firewalls throughout this entire structure. Mm-hmm. And so, if we can, express that to the architects who can then, pass that on to whoever their estimators are, mm-hmm. then they can have a much more informed decision. Is it worth putting all these firewalls in? Or is it, going to be a better value for the building and the owner if I just sprinkler it to a full NFPA 13 system and now I can get rid of all these firewalls and build this without any of these additional features that might be required because we've got an NFPA 13 R system.
Yeah. I mean, I think a lot of architects or building owners may think they're saving money by not hiring a fire protection consultant up front. But really, we get so many calls from where there was not a fire protection engineer involved. Yep. And there's a huge miss. And the fire marshals saying, hey, you can't move into this building yet. You missed a smoke control system for this atrium or things like that. Or, no one, they were delegating the design of the sprinkler system to the contractor and no one even thought about looking at what kind of water supply is available. And so the sprinkler contractor comes to do their shop drawings and they're like, hey, we got the flow test and there's not good water. We need a fire pump. Yeah. And suddenly the team's scrambling with, huge change orders or whatever and trying to figure out, okay, where's the real estate that we could put in a fire pump room? Yeah. And, now we have to upgrade the electrical and now we either need a diesel fire pump or we need an electrical generator for power backup. So there's things like that a fire protection engineer could hopefully catch up front that just add to huge challenges as you're either late in design or as construction starts and these issues are identified.
Yeah, I mean, at the risk of sounding like a total like nerd to the contractors and developers out there, I see it as critical as an architect in my mind. It's like as important to have them as early as an architect on the team. And it's just the problem in our market, like commercial, everybody's trying to get to the cheapest consulting. And then they look at those cheap consultants like, why didn't you catch this? It's like, well, because it's not our profession. We tried to, so if we're on our instant quote on our website, for example, we're trying to think of those things that might key in a warning right before we send the proposal. One of them is storage. Boom. Hey, careful, storage, right? Other categories like I2 and I1 or whatever, obviously there's going to be smoke control, these kind of things. If their building is a high rise, pressurization, so that we can say, hey, if you don't have, do you have a life, we will require them to answer, do you have a life safety professional on this project? Yes or no? And if they say no, do you understand that we have excluded a lot of services and we depend on the information that would be given to us by that professional and that you're still opting out of having them on the team? Yes.
You have that in your...
We're working that out right now because there'll be a matrix of like the categories that they choose will bring up little flags. And we have like a back end on the admin side that will be able to bring up what flags we want. And that's a huge one. Just putting it like right there. Call these folks, please, for the love of God. We are not doing this work for you. We do not interpret that code. What we have to be told by that expert who understands the hazards of all the materials And then electrical will be a huge one. Imagine, and it'll be the thing. Somebody comes in and says, this needs to be explosion proof. Of course they're going to look at permanent engineers, but Carter, why didn't you spec that explosion
Yeah, it's in
proof?
the NEC.
Yeah, right. It's like, because it's excluded to do that. We tried to tell you, lady. That's from one of our videos. But yeah, that's to us. We're trying to integrate that. Just go there, But I wish everybody would just start day one with them, even if it's an hourly thing, just to say, hey, can you attend this meeting? Just to listen in and give me the warning signs. And once we're safe and we don't need that formal, essentially what it looks like is be hourly until you see a need to have a full proposal. And if we get along through the SD and we're moving along and safe, then see you next project.
Right.
Or if we've made a decision where we need that study, then give me that proposal. I think that I'd love to see every single project go that way.
Max said you guys are using the word offense at
Oh,
KLH.
yeah.
That's kind of, we
big
call
time.
it proactive. It's kind of the same
Yeah.
thing. It's like, we could just send it out and then 8 months from now, something comes up with the fire marshal. It's like, well, I mean, it's not in our scope. We've been trying to be more proactive and letting folks know that up front.
Yeah.
Well, I think we're about to get there, so we'll have to wrap up. Any other final thoughts before we do from you guys, little warnings that you would give people and as they're starting a project with lessons learned,
Ooh. I'll let you go first. Yeah.
Lessons learned, man. I keep a running list. It's like that's how you become a better engineer, right? Is from making mistakes and learning lessons.
Yeah.
I mean, just specifically, I mean, there's just so many things that the fire protection engineer needs to think of and plan for and ask the owner. I like Sean's idea of having a list of questions that we ask every client.
Yeah.
I certainly like that. I think I might steal that and run with that.
We might have to have a separate conversation as engineers and just come to one of those fire protection meetings in like the MEP world and just kind of think through like what kind of things should we just be covering together,
But in general, I say, as far as all the areas that fire protection engineers cover, I mean, just make sure you're looking, you reach out to a consultant that has the experience with the type of fire protection project that you have, whether it's smoke control or sprinkler, fire alarm, storage.
And a contractor with that experience too.
Right.
That's done it. That's a huge
Absolutely.
one. That was on my notes, but experience matters for risk. Don't hire the cheapest person when you have that kind of requirement. Hire the person that has the experience. If they're the most expensive person and they're the only one they experience, there's a reason they're more expensive.
Right.
Don't hire the person that doesn't have the skills 100% every single time. And then that way your contingencies actually will represent a fair contingency. Otherwise, your contingency is nonsense because you hired an inexperienced professional not coordinating the scope gaps on that report. And it ends up being a nightmare destined for a lawsuit. Just go for the experience every single time. Yeah. So we're going to have to wrap it at that point. I wish we could continue. We'll have to do another fire protection
this has been fun.
episode.
Absolutely.
Man.
Yeah, I love it.
We appreciate y'all.
Thanks for having us on.
Austin and Sean. We'll put a link to y'all's websites and any socials that you want. We appreciate y'all coming out.
All right.
We'll see y'all next time.
Take care, guys.
Thanks a lot.